All right, so we know that the period is the reciprocal of the frequency. So we're given a frequency of 4 hertz, so we just take the reciprocal of 4 hertz. That's going to be, the reciprocal of 4 is 0.25. The reciprocal of hertz is seconds, and so there's our answer. The second question, normal incidence, the angle is formed between the normal line and the boundary of the reflective object is 90 degrees. This is the definition of a normal incidence angle, is one that is 90 degrees to the boundary of the reflective object. Number 3, what type of scale is decibel is a mathematical representation of? It is a relative scale and it is a logarithmic scale. So you always are taking the relative values and finding the logarithmic difference between them. Next question is, what is the frequency of this wave? There's a picture given. We have 1, 2, 3, 4, 5, 6 cycles in 1 second. Therefore, the answer is 6 hertz, or 6 cycles per second. Next question is, in soft tissue, what is the attenuation coefficient of a 10 megahertz ultrasound beam at a depth of 10 centimeters? And we defined the coefficient as decibels per centimeter times megahertz. And as your book says, that the attenuation of coefficient is the number of decibels, or 0.5 in soft tissue, times the frequency, gives you the coefficient of friction. So the coefficient of attenuation. The frequency is 10 megahertz. And as the book says, you divide that by 2, which is 5 decibels per centimeter. And that is the answer to what is the coefficient of attenuation. This is straight from the book. Next question, 143 millimeters is the same as, and the if we think of milli as a thousandth, we could read this as 143 thousandths of a meter is the same as, and then you could just simply find the answer as being 143 thousandths of a meter. So that one's pretty straightforward. You can also do the conversion if you want to. If we do the conversion of millis into meters, we find that what we can do is just write out milli as what it is, milli. And we can multiply anything by 1, so we're going to multiply milli by what its meaning is 1/1000th. So 1/1000th over milli equals 1, so we can multiply 143 millimeters by 1, and that's going to equal 143 meters. So that's how you do the conversion for that. Next question, sound is a blank wave. Sound is a longitudinal mechanical wave. That's a definition straight out of the book. So that is the answer to that. Which of the following terms does not belong with the others? Normal, orthogonal, perpendicular, or right angle are all different terms for a right angle. Oblique is the one that does not fit, so oblique is the correct answer. Propagation speed is determined primarily by the stiffness of the medium, and we've gone over that several times. Density does play a role in the propagation speed, but not nearly as much as stiffness. Which of the following is not the same as axial resolution? It was pointed out to me that this question was out of Chapter 10 instead of out of Chapter 6. So I removed it from the test. So the test will now be worth 49 points instead of 50. If you got the question right, then you've lost that point. If you got the question wrong, then it was removed. Pulse repetition frequency, next question, refers to the number of pulses occurring in 1 second. So that's straight out of the book. Most of you got that right. Next question. With normal incidence, if the propagation speed of media 2 is greater than media 1, what happens? So normally, because the propagation speed will affect the impedance Z, that means that now we have a difference of impedance in our two media, therefore reflection will occur. Transmission may occur, we don't know, depending on the angle and the type of boundary. Rarefaction may occur. We're not given enough information to determine if rarefaction occurs because we don't know we don't know enough about this. Sorry, I completely misstated that. Rarefaction will not occur because it is normal incidence, so neither refraction can occur. Refraction will not occur, but neither will rarefaction. So rarefaction and refraction are not the same. Rarefaction, of course, is the low pressure zone in a wave. Refraction is the bending of the transmission. Neither one occur in this situation. The correct answer is reflection. All right, next one. 3 centimeters is the same as, again, this is just like the 143 millimeters above. You can calculate it the exact same way. So it is the same as 0.03 meters. Next question. Sound traveling in jello passes through an interface at 90 degrees and continues to travel in whipped cream. The impedance of jello and whipped cream are nearly identical. What percentage of the intensity is transmitted? If we think about our equation for reflected incidence or reflection, we know that it is the difference of impedances over the total impedance, and that quantity squared. So if they're nearly identical, then we can say that the top portion of this equation is probably going to equal something like 0.001. Those would be nearly identical impedances, the difference between them. And so if they're nearly identical, then the bottom equation of Z1 plus Z2 would be something close to 2. So if we just put that into an equation, we square it, we end up with somewhere around R is equal to 0% or 0.1 or 0.001%. And so the best answer that's close to that, remember the transmitted is R minus 100% equals the transmitted, that should be 100% minus R is the transmitted percentage. And that's going to be somewhere around 99% for this example. What is the period of a 5 megahertz transducer in soft tissue? So if we remember, this is just like question number 1, where the frequency was 5 megahertz. The period is the reciprocal of the frequency. So the answer is 0.2 microseconds. Reciprocal of 5 is 0.2. Reciprocal of mega is micro. Reciprocal of hertz is seconds. Which of the following is not a component of attenuation? Remember, attenuation is absorption, reflection, and refraction, so power is not a component of attenuation. Okay, next question. Stiffer media have blank sound speeds. They have higher speeds. Stiffness is what makes the speed for the most part. Next question, what type of scattering happens when the reflectors are much smaller with respect to the wavelength? That's Rayleigh scattering. That's straight from the book. Ultrasound is any sound above 20,000 hertz or 20 kilohertz. So our answer is number 1. Next question. The maximum variation of a variable from its mean describes the amplitude of the mean. Next question. The unit that is used to describe acoustic impedance is the rail. And typically it's in the range of megarels. Human body somewhere around 2 to 3 megarels. Which of the following has the fastest propagation velocity? The stiffest of these is bone, so therefore the fastest propagation velocity is bone. Next question. The name of the physics laws that describe refraction is known as Snell's law. I told you had to remember that, and there it is. Which type of pulse will have better resolution? Short pulses. Everyone got this correctly, so I'm not too disappointed in you. What type of ultrasound has a duty factor of 100%? That is a continuous wave. Again, everyone that got that got it correct. If the beam area decreases, what happens to the intensity? It increases. Again, anytime the area, the intensity equals the power over the area. So if we have, let me go to our, since power over area equals the intensity, if this goes down, this goes up. If this goes up, this goes down. They are reciprocals of each other. If you have two waves directed in the same direction and appear to be in phase, the ending result is considered constructive interference. Again, if we go back to our picture here, let's see if I can clear the screen somehow. All right. If we have two waves and they appear to be matched perfectly, the resulting wave will be twice as big. This is constructive interference. They add together and it results in a larger wave. The propagation speed of soft tissue is best described by 1540 meters per second. That's the same as 1.54 millimeters per microsecond, or 1.54 kilometers per second. There's all different ways of saying the same thing. Next question. A sound wave with an intensity of 50 watts per centimeter squared strikes a boundary and is totally reflected. What is the intensity reflection coefficient? If it is completely reflected, it is 100% reflected, and therefore 100% is the correct answer. A sound wave with an intensity of 50 watts per centimeter square strikes a boundary and is totally reflected. What is the reflected intensity? If it's completely reflected, the intensity remains the same and it stays at 50 watts per centimeter squared. Next question. The time from the start of one pulse to the next pulse is called the pulse repetition period. With oblique incidence, if the propagation speed of media 2 is less than media 1, what happens? Again, this is oblique incidence. We're talking about Snell's law, and so the answer should be refraction. I will go in and fix this question. I see that I've misspelled refraction as rarefaction, so we will correct that. The smaller the acoustic impedance mismatch, the blank reflections. So the smaller the acoustic impedance mismatch, the closer the impedances are, and therefore the smaller the reflection. Which of the following is not an acoustic variable of sound? As it propagates through tissue, voltage has nothing to do with the acoustic variables. Pressure, density, and particle motion were the ones that we defined as acoustic variables. The Greek letter lambda is used to represent what sound wave parameter? That is used for wavelength. What type of reflection occurs from a surface that has a smooth, large boundary? This is describing a specular reflection or mirror-like reflection. Amplitude and intensity are indicators of the sound's what? These are all indicators of the sound's strength, the power. What is the pulse duration of a 4-cycle pulse with a period of 0.5 microseconds? So we simply multiply 0.5 times 4. That gives us our pulse duration of 2 microseconds. Which of the following is the correct distance equation? Where d equals distance, r equals rate, t equals time. The correct distance equation is d equals rate times time. Which type of reflection causes the most intense echo? Specular reflections cause the most intense echo. Next question. The amount of time that the pulse lasts is called the pulse duration. Next question. In soft tissue, what is the total attenuation of a 10 megahertz ultrasound beam at a depth of 10 centimeters? So now we have to take our equation for coefficient of attenuation, multiply it out, and come up with an answer. If we remember our equation, 0.5 decibels for soft tissue times centimeters times megahertz equals, so we went 10 centimeters deep, and we had 10 megahertz, and that's going to equal for us, first off, the megahertz cancel, the centimeters cancel, so we know that our answer will be in decibels. 0.5 times 10 is 5, times 10 is 50. So the correct answer should be 50 decibels. Obviously, I need to change that units to decibels. I'm not sure how that happened. All right, we'll fix that. A wave's intensity is 2 milliwatts per centimeter. There's a change of 9 decibels. What is the final intensity? So basically, we've doubled it, and doubled it. So the correct answer should be, whoa, I need to go in and fix this. So this is the correct answer, 16 milliwatts per centimeter squared. And so I will go in and correct that for everybody. Next, this image is depicting what type of tissue interaction, and this is refraction. Good, most people got that. Next question, which of the following is probably not a specular reflector? The kidney is not. The diaphragm definitely is. That was given to us in the book. Heart valves are, and biopsy needles are. So kidney is the correct answer. Most of you got that right. Very good. The amount of time that transpires between one compression and the next compression is known as the period. Attenuation increases with increasing frequency. Correct. Absorption is typically converted into heat energy in diagnostic imaging. So everybody got that correct. That's nice to see. The bending of the beam as it crosses an interface with a change in the propagation speed and oblique incidence is known as refraction. That's from Snell's law. Next, a sound wave strikes a boundary with normal incidence. The impedance of the two media are identical. What percentage of the beam is refracted? So since the impedances are identical, there is no reflection. Since it is coming in at a normal incidence, there is no refraction. So the answer is 0. And so most of you got that correctly. Good. Frequency is inversely proportional to wavelength. Good. Most of you got that. Wavelength times the number of cycles in a pulse is known as the spatial pulse length. Next, calculate the pulse duration for a 3 megahertz transducer in soft tissue with a 4-cycle pulse. So first thing we do is we take the 3 megahertz and we find the pulse duration, which is taking the reciprocal for a single cycle, is going to be 0.3 microseconds times 4, 0.3 times 4. The closest answer is going to be 1.3 microseconds. If you do the math, though, in retrospect, 0.2 is very close and should probably be considered. So I'll be adjusting that. Nobody picked that, so I'm not going to worry about it. Next question, which of the following waves has a longer wavelength? Well, we have a measuring tool down here that gives us distance from 0 to 12. Obviously, this wave comes in at about 4, this one comes in at about 2, so the top one would be a longer wavelength. Thank God, everybody, most people got that. For a sound wave, the energy is transported by a series of blank and blank of the median particles. And this is compressions and rarefactions. Next, which of the waves demonstrates a higher frequency? If we recall that shorter wavelength is higher frequency, we can see that wave B is going to have the higher frequency. If the impedance of two media do not change, what happens to the sound wave? It is transmitted. It just continues on. If there's no reflection, then the sound wave just continues. Next question. With normal incidence, the angle in degrees formed between the incident wave and the normal wave is 0. So the difference between the incident wave and the normal line would be 0 if the incident wave is a normal line, which is what this question states. So 0 degrees. The term anechoic means without echoes, so the Correct answer is the first one. Last question, 10 to the 6 is the same as mega. That concludes our review of the midterm.